Hello, this is Junichiro Horikawa, and today I'm going to create a visualization for this algorithm called Insertion sort in Houdini from scratch. And let me just explain how this sort algorithm works. So say you have random numbers in different order, like random order, and the way it works is to starting from the left hand side, and first of all you define that this first value 4 has been sorted out, and then you go to the next number and compare this number together with the previous numbers. And if the number that you're looking at right now is bigger than the previous one, then you can just skip it and go to the next one, and then you do the comparison with the next one with the previous 5. And in this case, the 5 is bigger than 3, so what you want to do is to replace those two numbers. And then you are still looking at this number 3, and you are also going to compare this number to the one that is previous to this number, which is currently a 4. And if you compare this, you see that the 4 is bigger than 3, so in this case as well, you want to replace this 3 with 4, like this. Now, there are no more previous numbers for 3, so you go skip to the next one, and then this has been already sorted, so you're not going to move this. Go to this one, and this one is also sorted out, so you're not going to do anything for this one. Go to the next one, then you have a number which is smaller than the previous one, so you want to replace it. So this goes to 1, this becomes 5, and if you continue doing it until this one goes to here, then you shift those numbers to the right side and continue doing that, and you'll be able to sort it out 1, 2, 3, 4, 5, 6, 7. Like so. So that's what I'm going to implement and make it as an animation. Now the sort itself is pretty simple in terms of algorithm, but what I want to do here is to create an animation looking like this in Houdini to show how this algorithm seems to work, as a kind of a practice for using subsolver together with the vex. Right, so this kind of animations. Alright, so let's try to do this from scratch. Okay, first of all, I'm going to create a null node, like I do always. And, oops, first of all, I need to have a geometry node. Then go inside to create a null node, and I am going to name this controller to have all the parameters that I want to control for this setup. Let me just create all the parameters that I need. First of all, I need a number of random values, so let's have it as numVals. Okay, from 0 to 10 is fine, I think. Okay, and since I'm going to create a random values to sort, I am going to create a seed for the random values. The range could be anything. Okay, so, and I am going to create a sorting algorithm using a box bar, so let's try to set some maximum height for the box. So I'm gonna name this box height from 0 to 10. Okay, and finally I am going to try to set up use some parameters in order to control how fast this animation should go through. And one rotational step, I want to set some step frame values in order to control the animation. So if the number is 5, then you use 5 frames to rotate from one point to another. Translate from one point to another point. So I'm going to name this step frame. And set the range between 0 to 50 for now. Okay, and let's set some random values. Okay, so the numVals 10 is okay. Seed could be any value. Height maybe 5. And step frame to be around 10 or 20 for now. Okay, let's set it to 10. Now the first thing I would like to do is to create a random values together with point. So I'm going to create a point using this number as a number of points, then apply each point with a random value, which you want to use it for the sorting. So what I'm going to do, I'm going to just create it using detail wrangle. So I am going to first create an attribute wrangle, set it to detail, and I'm gonna name this init in terms of initialize. Then first of all, let's have a parameter to control the number of points. So I'm going to first create a parameter value for the integer, then link this value together with this channel slider. Okay, now it's been linked. Now let's use a for loop to create a number of points that I need using the number channel that I have promoted. Okay, and let's create the random value using random function and multiply it with the height, maximum height, so that I can use it as a height value as well. So let's multiply this. Let's bring this height value to this channel. Okay, and I think I need to set some seed value for the random. So I'm going to first apply a seed, and let's also link this from here. Copy, paste it right here, like this. Now, since I have 10 points, I don't want all the points to have all the same values, so I'm going to multiply this seed by I plus 1 so that all the numbers will be different. Okay, what is this? Okay, well, right now I am using the newest Houdini version called 18.5. So there might gonna be some errors, but hopefully not. Let me just save it so that I don't lose the process. Insertion sort. Okay. Now what seems to be the problem? Yeah, I am missing that multiplication. Alright, now that I have a value, a random value, let's create a point. Using I as an x coordinate value. Okay, alright, I forgot to do add point function. Right, like this, like this. Okay, now that I have all the points arrayed on the x directions, next thing I would like to do is set a attribute to store this random values to each point. So set point at riv. Let's just name this value at pt with this random value. Okay, now let me also set a ID for each point, which is going to be the initial ID will be similar to the point number for each point. So, and I am going to use that ID in order to determine where that point is currently based on the extraction in terms of the sorted out value. So I'm going to name ID pt with pt num like this. Okay, now let's check. If you go to the geometry spreadsheet, you'll be able to see all the attribute that has been added, and okay, something is wrong, doesn't look correct for the ID. Okay, now, oh yeah, I cannot use ptnum because I am inside the detail, so instead I should use I. Okay, looks good, and the value seems random enough. Right, let me try to change JC so that to check. Seems like all about, oh, okay. So I have multiplied the random value together with the height, maximum height. So the maximum height is 5, so it's in between 0 to 5. So that seems correct. Alrighty. Now all those looks good in terms of initial values. Let me also visualize those values so that I can check what's happening at each iterations, since I'm going to use a subsolver later on. So I'm going to create a marker to show up first of all ID, and let's color this with yellow or something, right? Now next I would like to add another one, which is to show the value. Let's make it green. Okay. Oh wow, I just have renamed this ID to value. Okay, I need to add ID again. ID. Seems like I cannot use ID anymore. So, okay. Is that because I used it somewhere? Seems okay. Alright, now let me also change the color. It's a bit hard to see. I'm gonna change this to yellow. And let's also make the text a bit bigger. So going to the visualize or maybe guides and set the guide font to large. Now it looks better. It's more easier to see what are these. And for the point number itself, you can check it from this toggle. Right. Now, maybe I want to show that as well. Okay, so these are the information that I need in order to determine if the sort has been successfully ongoing. Now let's also color each point based on the height value. So color, set the ramp from attribute, and the range is between 0 to 5, which is this height value. So set it to the range max. Like this, right here. Okay, now the attribute name is equal to value. And let's change the color from, say, green to red. Okay, now let's check. Okay, seems to correspond to the value. Now let me also change the size of the point itself for the visualization. I can change it right here. Yeah. Okay, now let's show up the marker again and the point number as well. Okay. Now what I'm going to try to do is to, well, since what I have explained, in order to use the sort insertion sort, you start from the left hand side, which in this case a ID or a point number is equal to 0. So I'm going to start with this one, and the first one will going to be just being considered as sorted out. And so you go to the next one and use this, start to use this one to compare with the previous one. And do the comparison between two, and if the previous one is smaller, I mean the bigger than the next one, then you want to switch it. But if this previous one is smaller, then you don't want to do anything. Then go to the next one. Now you do the same things, compare this one and this one together. Now at this point, this is still smaller, so you go to the next one. Then in this case, this number 3 points is smaller than the previous number 2 points, so you want to switch it. Now after you switch it, you want to this point goes right here, and you want to compare that one with the previous one as well, and that goes to the left, and so on. Now to determine where you are at right now, where to start the comparison, I am going to create a group to determine which point is currently the last point. So I am going to name the group as last. Set it to primitive, set it to point, set to last, and set the first point to be the last one for initial setup. Okay, now let's also create a point which point is currently animated, so that while the point is animated, you don't want to go to the next point to check the sorting. Check the comparison with if the previous one are larger or bigger. So I am going to create another group for the point, and let's name this as moving, and I'll do that to the first point. Well, actually currently no points. Initially no points is moving, so I don't think I want to store this in any points. So you just have created the empty point group. Well, in this case it doesn't really show up because I haven't said anything, so maybe I don't really need this for now. Okay, now for the last one, let's make sure that it is showing. Yeah, it is, so that's good. So I'm just gonna name this last. All right. Now next thing I like to have is a attribute which stores while it's animated, the point will going to rotate, and in order to switch the position. So I need to do that, I'm going to use the rotation transformation. So to do that, I need rotation angle to be stored somewhere so that I can use it later on. I can use it for the next iterations on the subsolver. So I'm going to create it as a detail attribute, since I only need one value for each frame. So I only need constant value. So I'm gonna set it to detail, or maybe I can just simply use attribute create node. Okay, and set it to detail and set it to float, and let's set the name to current ang, like this. Okay, now in order to rotate, you also need the original positions. While the point is moving, you want to refer to the original position to determine the next rotated positions. So I am going to get the current point positions using rest node. So as a result, you'll be having a copy of the point positions as a rest attribute, like this. Okay, we're gonna use this as well. Okay, so that's enough for the initializations for the setup. Let's start to use subsolver to actually create an animations. So we're going to start from the left hand side, right? And in order to start from the left hand side, we need to decide some conditions, which one to start. So the one that I want to start is the one that has a group called last. So I'm going to first create a point wrangle, and I'm going to filter this point wrangle with the group called last, which is always going to be the single point. So this could also be like a detail wrangle, but using point wrangle with a filter is much easier, so gotta do like this. Now I'm gonna name this insertion sort, which is going to be the core wrangle in order to control the animation. Okay, so hopefully we could do this, go through this. Now let's first try to bring up some parameters from the node controller that we have made, such as a step frame value in order to control the speed, which was integer. Okay, Let's promote this and go back to the geometry node. Then copy the step frame, copy this, go back to the subsolver, paste it right here, paste the reference to link. Oops. Like this. Now make sure it's being linked. Okay. Now the first information that I would want to get is the ID value for the last group point position. So in this case, the first pointer will be this one. So let's get this ID value using a point function. So I'm gonna name this as a current ID using point 0 ID at ptnum. So this will be the current point ID value. And in order to do the comparison with the next one, we want to have the next point ID as well, or point number as well. So first I'm going to retrieve the next point ID, and that ID is always going to be CID plus 1. That's the rule that I have just decided on. Whenever you change the point positions, the point number wouldn't be able to change, but I want the ID so that at any even if you change the point position like a lot of times, you want to keep the ID as going incremented by 1 from left to right. So whenever you have switched the point, like for example from point 1 to point 2, the ID will also be switched, but right after you have switched, you want to switch back the ID again so that it is always going to be, the ID is always going to be starting from 0 and go up by 1, so 0, 1, 2, 3, 4, 5 and so on. So that's the purpose that I'm having this value. Okay, now from this ID I'm going to retrieve the point number, and the current point number is just equal to ptnum, so that's pretty simple. But the next point number is not actually a ptnum plus 1 because there is a chance that you have already switched the point positions. So this cannot be at ptnum, but actually you can retrieve this value by using this ID value, which is always from 0 to 0 and incremented by 1. So what I'm going to do is to use this ID value to find out the point number. And to do that, you can use a function called find attriv val. Okay, and you are looking at the point class attribute ID, and I want to get the point number from NID, which is going to be the next ID number. If you're looking at, if this one's the current ID, then this is the next ID. Okay, now let's also retrieve the value for each point as well. So meaning this green value, the random value, in order to use it for the comparison. So point 0 value at cpt float and val. Let's just make this small. And val is equal to point 0 value and pt. Okay, now at this point let me check if there's any errors. Okay, looks good. Now let's go to the next step. Now let me also retrieve the angle value from the detail that I have created, which is called as current ang detail. The name was current ang. Okay. Alright, so next step, what I'm going to do is to check whether I should go to the, whether I should skip the current frame or not. Now, the situations you want to skip the calculations is when the last group has been reached to right here on the end of the point, meaning there are no longer sort actions being needed. So that's one situations you want to stop the calculations. And there's also a situations you want to stop the simulations. That is by setting a starting frame. You want to prevent doing any calculations until the first the starting frame number that you have specified. Well, that is because, well, maybe it's some of you might not want to start calculating the steps or doing the visualization from the first frame, but you want to keep it at till some of the frame, like same as the step frame value. So in that case, you want to you need that kind of conditions as well in order to ignore the code afterward. So let's say if you want to start right after the step frame, the value of the step frame have been reached, then you first check your current frame. Then if the current frame is less than step frame, then you don't want to run the code in order to animate the sorting algorithm. So in that case, I can just say return to exit the code. Now, there are other situations that I said, that is when the point went to the last point number or positions. So in that case, I can check that by checking the ID for the current ID. And when the current ID is equal to the number of points minus 1, then currently there are 10 points, and 10 minus 1 is 9. So if the ID is equal to 9, then you wanna stop it, because you are only looking at the last point. So if the last point ID is equal to 9, then you want to stop it. So you want to do return as well. All right. Now let's go to the next step. Okay, so let's try to actually animate the point first of all. Now to do that, you need to retrieve the position at each point, and I am going to retrieve the rest point positions, which is not the actual point positions. Actual point position will be modified by the rotation, so I'm not gonna retrieve that. I'm just going to set the point positions, but for the in order to actually define where the next point should go, I will use the rest point position together with this current ang. So the current rest position can be retrieved 0.0 p rest and cpt, and next rest positions can be retrieved 0.0 rest at npt. Okay. Now first thing you want to do is to check whether the current point is moving or not. So if in point group moving group, now currently every point doesn't have a moving group, so the code starts from this process inside its conditions. Okay, so if in point group for the moving at C point, meaning the current point is equal to 0, so meaning if there are no points that has moving group for the last group, then and what you want to do is to, well, maybe you don't want to do anything and just skip what I'm going to do for the else one. If the point is moving, then you actually want to move the point. And in order to move the point, what I'm going to do is for this point, I'm going to use this middle point between 2 points that's next to each other and rotate it by 180 degrees. And this one as well, rotate it by 180 degrees, maybe to counterclockwise. Okay, so to do that, you first need to define the middle point positions right here, right? So let's do that. Okay, so that is let me just create another condition saying if point is this value, and just say 1 instead of using else, because I'm going to use the else for other purposes later on. Okay, now I seem to have some errors. Where is that? Okay, says syntax error unexpected equal at 14. Okay, should be equal, right? Okay, so when you want to move, then first of all you want to have the middle point right here in between the rest position 1 and rest position 2, which in this case a value that I have retrieved as CRES and NRES. So name the middle position as MPOS and create this by adding 2 rest positions. Okay, and multiply by 0.5 to get the middle point. Now, when you want to move, you actually want to rotate, right? And I'm going to use this rotation angle in order to actually determine the point positions. So at each iterations, when the point is moving, I'm going to increment this angle, the current angle, by a step angle that should be derived from the step frame. So let's calculate the step angle based on this frame value. And since the final calculation value should be 180 degrees, so what I'm going to do, I'm going to create a step angle and calculate it by a 180 degrees, which is equal to pi by a step frame value. Okay, so this is going to be the step angle. So using 10 frames to add this step angle to the current angle. So in the end, it starts from 0 and at the end it goes to 180 degrees in 10 frames. So that's the purpose. And let's try to use this. Okay, so at each step for the moving point, I'm going to increment the current angle with the step angle. And you want to make a condition when to stop this animations, and that is when the current angle goes over 180 degrees. In that case, you want to set the current angle to pi. You want to cramp it to pi. So, well, you can write it other way, I guess. So current angle is min current angle pi. This is the same. Okay. Now let's actually use this current angle in order to rotate the point positions. Okay, so to do that, Well, first of all, let me just update the detail attribute for this current angle, since for the next frame we're going to use this updated current angle. So set detail attrib 0 current ang as updated current ang. Okay, now I'm going to create the rotational matrix by first creating a ident and create a rotational matrix from this mat matrix current ang, and I'm gonna use the y-axis for the rotational axis. Okay, now it's the time to actually set the positions for this point and this point. Now let me just do from this point the next point. So for this one, I need to set the middle point, which is going to be the center of the rotation, to be placed on 0, 0, 0 coordinate. So in order to rotate using the matrix. So I'm going to update the next rest positions by subtracting by m positions. Then do the rotation by multiplying with the rotational matrix. Then bring m pos back so that it will be I'll set it back to rotate like this. Okay, and finally you need to also update the point positions for the next point, which is this point. So set point attrib p and pt with this and res, updated and res. Now I'm gonna do the same process for the current point. So I'm just going to copy this all. Okay, and paste it, and let's rename this to CRES and CPT. Okay, all right, now seems to have an error. Where is that? Steph rem. Okay, I think some spell mistake, which is where it is. Okay, this one. Okay, now's the time I could use to check whether the point is really moving for the first point and the second point. Okay, so let's save this, go to the geometry node, and let's try to play it. Okay, nothing is happening, so I think I'm missing something. That is, this moving point only works. Moving function only works when the group is inside the moving group, and currently I didn't set any group for the moving in anywhere, so I need to do that next. Okay, so where I can do that, well, the position where I can do that is right here. So right after I have checked if the point has the moving group or not, then if not, then wait, let me think. If not, maybe that will be the timing. I should set the group, so it should be right here. It should be somewhere inside here. So if the point group is not moving, then you wanna start moving the point, right? So set point group moving for current point with 1. And if we leave these conditions with grouping moving 1, then this will start to activate it. Now let's check. Play. Okay. Now I waited a little because I have set the step frame to be a starting frame to wait for the waiting time. Okay, so it should be starting from somewhere that is equal to this step frame, which is right now 19. Let's just set it to 20 so that it's easier to see. Now, after 20, you see that the point has started to move. Okay, so the first movement seems to be okay. Now, it is just rotating without any comparison looking between these point and these point. So in reality, using insertion sorting, you actually don't want to switch those two because the previous one is smaller. So this should not happen, so we need to give that kind of conditions. Next. Okay, go back to SOP solver, open this up, and let's try to create that conditions. Now, the position, in order to do that, we need to check before setting this point to move whether the previous point is smaller than the next point. So somewhere right here. So if the current random val is smaller than n val, then you don't need to use this current point as an animation moving point, but you can just set the last group to the next point so that the last point can compare with the next point again in the next frame. So that's what I'm going to do here. So set point group. First you want to remove the last group from the current point, so cpt 0 set, and you want to set the group to the next point with the last group as 1. Okay, and finally you want to exit the code in this frame so that all those code afterwards will be ignored and go to the next frame time-wise. Okay, so that should be good. Now let's click apply and check the movement again. So the first one has been ignored, as you can see. So going like this, and once the left part is bigger than the next part, then it start to do the switching like this. It's working. Now after this, it doesn't move anything, so we need to do a little bit more to this in order to work continuously. Okay. Now next things that I want is after the current angle reached to a pi, then you want to, meaning after the point has been switched, you want to replace like a value like ID and the rest positions and reset the current angle to 0 so that you can go to the next step to choose the last group to continue calculate. Okay, so let's do that. So that can be written when the point is currently moving. When the current is currently moving, and also if the current angle reaches to pi, meaning that's the end point where the point should be moving to, then in that case you want to first set the point moving group to be 0. So you want to stop the point be moving so that you don't have to activate the next code right here. Okay, so CPT 0. Now you also want to set the detail attribute, call current ang to 0, so reset the current angle to 0. So for the next moving code, you can start from 0 angle. Okay, now next step, you want to right after you have switched one of the points, then it's unable to change the point number, but you can actually change the ID. So to keep the ID goes from 0 incremented by 1, so 0, 1, 2, 3, 4, 5. You also, what you want to do is to switch the ID as well as soon as the point has been switched. So set point attrib 0 ID, and for the current point you want to switch with the NID, which is the next point ID, and do the same for the next point. So set point attrib 0 ID. For NPT, you want to switch with the current ID. So this is the first switch. Then you want to do the similar things for the rest positions, because the rest positions for each point is also a multiplication, based on the X positions right here. So you want to update it right after you have switched point positions. So I'm gonna copy these, paste it right here, and update rest for each current and next point with the nres for the current point and cres for the next point. Alright. Okay, no errors. Right. Now next, right after you have switched, say, well, maybe this one. So right after you have switched between the number 2 and number 3, then what you want to do next is that this point goes to right here, right? Now, what you want to do next is you also want to compare that number, which came here, with the previous one. So what you want to do is to move the last group to the previous number, previous ID number from the current ID. So that's what you want to do. And if you find out that this value is smaller than the next switch value, then the last group will just go to the next, will be skipped to the next one. But you want to make sure that you first check with the previous one, so that you don't have to, so that the point can go to the next point without any problem. Okay, so to do that, first you need the ID, which is -1 to the current ID. So let's name this PID in terms of previous ID, which is equal to CID current ID -1, right? And you also want to find out the attribute, the point ID, actual point number for this ID using the find attribute, which I have used right here. So I'm going to copy this and paste it right here, and I'm going to retrieve the previous point number using the point ID and PID, like this. Okay, now and after you have done this, you want to make sure that the PPT, the point number, is actually a bigger than 0 or equal or bigger than 0. If it's negative, then that means you couldn't find that point position, so it might be it's at the end of and left point, which means there are no way that you can set a previous point. So in that case, if that's not the case, if the point ID is equal to 0 or bigger, then you can set the last to this point PT, previous PT. So in that case, you also want to remove the last group from the current ID, current PT, current point number. So set point group 0 last CPT to 0 first, then set point group 0 last PPT to 1. Okay. Now I think we have done a lot of conditions right here, and let's see now if this start to work or not. Okay, going up and start. Okay, looks good. And the small values goes to left until you find the smaller value on the left side. And this seems like to work well, and it is going okay until the last one. Let's also see until the last. Okay, the 0.8 is going left until you find the smallest value. Okay, I might need more frames. Let's set it to 700. And okay, so there seems to be no more animations, meaning all the code, I think the code has been skipped by these conditions right here. So that is around frame equal to 180 or 90. So I'm gonna keep it as for 500. Okay, now and let's check the final value if it has been sorted out. So starting from 0.1, 0.2, and so going to 4.3, and seems like it has been sorted out successfully with those animations. All right, so it looks good. Now is the time to use those points to place any kind of geometry you want in order to visualize it as an animation, so that you can also render it. Just gonna use the simple box like the last time when I did the bubble sort. Okay, and I am going to use copy to sop. Copy to points sop. Okay, now I just realized I need to scale up the box based on the random value that I've stored in each point. So let's create another wrangle, point wrangle, and create, or maybe I can do this beforehand, before going into the sop solver, because the actual value itself would not gonna change for each point. We're just gonna keep it as it is. Only the ID and the rest position is going to change. So we can create the scale attribute right here, right before going into the subsolver. And what I'm going to do is to create a vector scale attribute, and let's set the x and z to 0.5 and set the y value to a float attribute called value, which is a random value. Okay, now the box is using the v scale, the vector scale attribute for the height and the x and z value. Now I also want to set the box so that it sits on the floor. I'm gonna set the center to 0.5. Okay, now looks good. Now let me also change the material to white so that it looks a bit brighter. Okay, now everything is set. Let's try to animate if this is doing what I have wanted. Okay, doing the rotate. You see that the small one goes to the left, and comparing goes to the left until you find the smaller one. Going to the left, stopped, and this one goes to the left until it finds the smaller one on the left side, and done like this. All right, now we have just successfully created the animation, a visualization for the algorithm called insertion sort. Okay, so that's it. That's how I did it. Maybe there should be plenty of ways to simulate or create this kind of motion graphics. If you have any idea in other ways, please give me some idea for that. That will be great. Okay, so that's it. Thank you for watching. If you find this video interesting, consider like it or subscribe to the channel. Would be great. Okay, thank you and goodbye.